Okay, hi there, Zach. We are going to do lesson number 43, and this is a really fun lesson. It goes over least common multiples and least common multiples of algebraic expressions. So it's really taking this idea of least common multiple, which you've been doing, to the next level and applying it to when there's variables involved, okay? So, for example, just a quick review. If we are given these numbers, 4, 5, and 8, and then you're asked to find the smallest number that is evenly divisible by each of the numbers. Now remember that even though we have the word L for least in least common multiple, we're talking about multiples. So this is going to be when you when you multiply a number by 1, by 2, by 3. So these are going to be huge numbers, way bigger than the numbers that they give us. We're not talking about smaller numbers than these. We're talking about way bigger numbers than these. But we're trying to find the smallest number of those huge numbers that is evenly divisible by each of these numbers. So to find that, sometimes what I do if I have a number like this is I take like the biggest one out of these. So I take like the 8, and then I do, well, 8 times 1 is 8. Do these go into 8 evenly? The 4 does, but the 5 does not, so it's not going to be 8. And then I take the 8 and I multiply it by 2. 8 times 2 is 16. Does 4 go into that evenly? Yes, it does. Does 5? No, it doesn't. So that's not going to be the least common multiple. Then I do 8 times 3 is 24. And 5 is not going to go into that evenly, so it can't be that. Then I'm going to do 40. 40 is the next one, okay? So then 40. Does 5 go into 40 evenly? Yes, actually it does. Does 4? Yes. So I know the answer is going to be 40 in this situation. But that takes a lot of time, and you can tell that if they start giving you humongous numbers like 31 or 157, that's going to take way too much time. So we need a process to make this easier to do. Okay, so all right, so let's see. Okay, what they said is sometimes what some people do is they just multiply all of these together. The thing that happens when you multiply all of these together, you would get, let's see what you would get. 4 times 5 is what? 4 times 5 is 20. And then 20 times 8, you would get 160. So we know that all of these numbers do go into 160. They're all 160 is evenly divisible by 4, evenly divisible by 5, and evenly divisible by 8. So that is one of the answers, but we don't know if it's the smallest possible answer. We do know, so for example, they say one thing to do is multiply all the numbers together. And then you can see that 160 is divided by 4 evenly because you're going to get 40. 160 is divided by 5 evenly because you're going to get 32. And 160 is divisible by 8 evenly because you're going to get 20. Well, of course, all those numbers go into 160 because you just multiplied those numbers together to get 160. But that's not necessarily the smallest number that is evenly divisible by the numbers. We want the smallest number. The smallest number is actually 40, and I got that with the process I did. But we need a process to be able to get it. So let's just prove that all of those numbers evenly go into 40. So 40 divided by 4 obviously is 10. 40 divided by 5 obviously is 8. And then obviously, since you just did 8 times 5, 40 divided by 8 is equal to 5. So we call the smallest number that can be divided evenly by each of a group of specified numbers the least common multiple. And the least common multiple is abbreviated LCM. Okay, so we're going to be finding LCMs. Now, you can find the LCM of some numbers by doing what I did and making sort of those mental calculations, but what if the number is humongous? That's what she said, right? So if the number is humongous, then you don't want to be doing those mental calculations. That's too hard. So here's the process by which you find the LCM in any group of numbers, no matter how big they are. Step number 1, write each number as a product of prime factors. Write each number as a product of prime factors. Don't worry, we'll go over some examples. Step number 2, compute the LCM by using every factor of the given numbers as a factor of the LCM. Use each factor the greatest number of times. This is important because sometimes people don't realize that they need to use each factor the greatest number of times it is a factor in any of the numbers. Okay, now he's like, why don't you explain this to me like I'm 5? Because when you explain it in words like that, it's just so hard to get. We have to explain it by actually doing that. That's how you learn math. So to demonstrate this procedure, we're going to find the LCM of 18, 81, and 500. Now, okay, these are humongous numbers. The answer is going to be humongous, right? And so this is, the first step was, let's go back and see what the first step was. Write each number as a product of prime factors. Okay, so write each number as a product of prime factors. So we take the number 18. And do you remember how to sort of write it as prime factors? If it's something that's divisible by 2, then I divide it into 2 and 9. And then 9 is not divisible by 2, but 3 goes into it, so I can do 3 and 3. And then these 3 numbers are the prime factors that are written over here, 2 times 3 times 3. So that's how I figure out the prime factors, okay? Then let's do that for 81. So if I have the number 81, I know that 9 times 9 is 81, so that's another way to do it. And then 9 can be 3 and 3 and 3 and 3. So these are the prime factors. Like I can't break that down anymore. 3, 3, 3, 3, and 3. 3, 3, 3, and 3. Okay, so there's 4 3s, and there they go. Okay, so they're right there. Now I'm going to do that with the number 500. Okay, so if I don't know where to start, let's just divide it in half. 2 and 250. Now I know that 250 can be divided in half because it's an even number. So that'll be 2 and 125. Now 125 cannot be divided in half anymore because it's an odd number, but 5 goes into it, right? So 5 would go into it how many times? Well, that would be, let's see, 20. Oh, heck, do I need a calculator? Let me get a calculator just because I hate when I make a mistake and then I have to go back and fix it. So it's going to be 5 times 25. And then 25 can be further broken down into 5. Whoa, heck. I hit a button. Okay, sorry. 5 times 5. All right, so now I've got my prime numbers here. It's 5, 5, 5, 2, and 2. Okay, so those are my numbers for 500. So it's going to be 2, 2, 5, 5, 5. Okay, now I've broken down all of these numbers into their primes. All right, let's erase this because this is so confusing. It's too much stuff. I don't like the messiness. Now, I write the factors and then write them the maximum time that they appear. So, what does that mean? I'm going to write the factors and then write them the maximum time that they appear. So, I'm going to bring this down so I have all of this information. I'm going to bring it down here. Okay. So now I'm going to write the factors and write them the maximum time they appear. So I'm going to choose a factor. Choose a factor, any factor. How about the number 2? Okay, so I'm going to write the number 2. But that is one of the factors, but now I have to write it the maximum time that it appears. So it's in the number 500 2 times. So I'm going to write 2 times 2. Okay. Now, I'm going to choose a factor, any other factor. How about the 3? So, there is a 3 in at least one of them, so that's okay to use a 3. It doesn't have to be in every single number. It just has to be in one of them. But I do have to write it down the maximum time it appears in any factor. So here I see it 1, 2, 3, 4. So I have to write it in my other list over here 4 times. So I wrote it once, 2, 3, 4. Okay, what's another factor? Are there any other prime numbers that I haven't used yet? Yep, the 5. And the 5 shows up 3 times in that last one. So I have to do 5 times 5 times 5 because it shows up 3 different times. And then if I multiply all of these numbers together, I'm going to end up with the least common multiple of all 3 of those numbers. So it's going to be 2 times 2 times 3 times 3 times, So I'm going to definitely need a calculator for that. So if you multiply that out, 2 times 2 times 3 times 3 times 3 times 3 times 5 times 5 times 5 equals, the answer that you get is 40,500. This is the least common multiple. Good thing we didn't do that in our head, right? Bam, there you go. That's the least common multiple. So let's go over some other examples. Why would we ever want to do this in real life? Well, unfortunately, you have to do something like this when you're adding fractions and finding a common denominator. You would have to find a denominator that can be divided by all of those other things evenly, right? So that's one example. But I'm sure we're going to get to more as we go through these lessons. So let's move on and go to example 43.1. I know what you're thinking. I just want it to stop. Don't worry, it's soon to be over. You got to know this stuff though. You got to know it. Just think how much smarter you're going to be than all of your other friends. Find the least common multiple of 8, 15, and 100. So the first thing I'm going to do is I'm going to write each number as a product of prime factors. And I'm going to do that my favorite way of doing it, which is to write an 8 and make these V's. It can be divided into 2 times 4. And 4 can be divided into 2 times 2. So 8 is easy because it is 2 times 2 times 2. Those are the primes. Okay, now let's erase that. And let's do the same thing with the number 15 this time. 15, I know 3 and 5 go into it, right? And guess what? 3 and 5 are both prime numbers. So that's all I got, 3 and a 5. Okay, now I'm going to get rid of that. What about the number 100? So if it's a big number and you don't know where to start, just start by dividing it in half. 2 times 50, right? And then the 50 can be 5 and 10, right? The 10 can be 2 and 5. And that's it. Those are my primes right there. So there's a few of them, 2, 5, 2, 5, right? So if I sort of write them in order, it would be 2 times 2 times 5 times 5. You don't have to write them in order, but I'm a little OCD that way. So, and it helps to keep things organized. So I don't think it's a bad idea. Now, to find the LCM, remember, we use each factor, every single factor that shows up, even if it shows up in just one of them, it's going to be used. And we write it down the greatest number of times that it appears, even though that seems weird because it's the LCM, right? Least, but we're going to write it down the greatest number of times it appears. So the first thing I'm going to do is, let's start with the 2. And I scanned through all of them. So there's 3 2s here, there's none here, there's 2 2s here. So I need it the greatest number of times. The greatest number of times is 3. So it's going to be 2 times 2 times 2. Okay, now I'm scanning through again, looking for another prime number that I haven't used. How about the 3? Okay, what's the greatest number of times it appears? Well, here it's 0, here it's 1, and here it's 0. So I just need 1 3. Okay, what's the next number that I haven't used? It is going to be this 5. And if I scan through, there's no 5s here, there's 1 5 here, there's 2 5s here. So I've got to use it twice. So I'm going to do 5 times 5. And if I multiply all of that together, that's going to give me my LCM. So I'm going to take my calculator And I'm going to do 2 times 2 times 2 times 3 times 5 times 5 equals, and I got the number 600. LCM equals 600. Hopefully you got that number too. I mean, as well. And so 600 is the smallest number that is evenly divisible by 8, by 15, and 100. So 8 goes into 600 evenly. 15 goes into 600 evenly. 100 goes into 600 evenly, obviously. All right, let's go on to example 43.2. Find the LCM of 30, 75, and 80. These are bigger numbers, so they're definitely getting a little bit more tricky on us here. So let's start with 30, and we're going to take it down to its prime, all right? Take it down to its prime. All right, so I'm going to start with the number 30. I know that 3 times 10 goes into it, so let's start there. 10 can be divided into 2 and 5, and those are basically my primes, so 5 and 2 and 3. Okay, so I'm going to write over here. I like to do it in order, so 2 times 3 times 5. Okay, erasey, 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 erasey. Next number. Next up is the number 75. 5 goes into 75, and it goes into it 15 times if I'm doing my math right. And I think that I am. Maybe someone check that for me. What is 75 divided by 5? Yeah, 15. Okay, 15. It can be divided into 3 times 5. So my primes are going to be 5, 3, and 5. See, it doesn't matter where you start. I could have started with like a 3 here and it ended up with something different, but you'll still get down to the same prime numbers. So that's why I like that method. So this is going to be 3 times 5 times 5. All right, done with that. Erasey, erasey, erasey. Now next number is going to be 80. The number 80 is up. Now, I'm going to do this a little different. I'm just going to do 8 times 10. Now, those are not prime numbers, so I can take those down further. This one's 2 times 4. 4 is not a prime number. That can be 2 and 2. Okay? Now, let's do the same thing with 10. 10 can be 2 times 5. And those are prime numbers, so I'm going to stop there. So what were all of my endpoints? I ended at a 5, a 2, a 2, a 2, and a 2. I don't count that 4 because I further divided the 4 into the 2 and 2. So you only do the numbers that are sort of endpoints or at the end of the branches. So for 80, I'm going to have 2, 2, 2, 2. There's 4 of them, and then a 5. Okay, so whoops, oh heck, I did not mean to go to that. It's some news thing popped up, and when I touched that up at the top, it went straight to the news thing. Sorry about that. Okay, so let's erasey this, and now I've got these 3 numbers divided up into their primes. So now I'm going to find the LCM, and the LCM is going to be each factor written down the maximum times they appear, right? So I'm going to start with the number 2. How many times is the maximum time it appears? Well, I scan through this, it's 1 time. Here it's 0 times. Whoa, here it's 4 times. So I need 4 number 2s. 4 number 2s. Okay, 3, 4. I'm just going to go to the next line. Okay, how about the number 3? Well, if I scan this one, it's 1 time. This time it's 1. Here it's 0. So I just need it 1 time. Okay, now I'm going to go for the next prime number. It's 5. And I'm scanning through. There's 1 5 here. There's 2 5s here. And there's 1 5 here. I need it the maximum time, which is 2 5s. So I write down 2. Now I have to do this multiplication. 2 times 2 times 2 times 2 times 3 times 5 times 5. And if I multiply that out, I could just cheat and look at the thing. What number was I on? 43.2. Okay, I'm going to cheat and look in the book. And the answer is, dun 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 dun, LCM equals 1200. So what does 1200 mean? 1200 is the smallest number that is evenly divided by all of these numbers, 30, 75, 80. That means 80 goes into 1200 evenly. 75 goes into 1200 evenly. 30 goes into 1200 evenly. And there is not a smaller number that can be evenly divided by all of those. This is the smallest. So that's the LCM. All right, one more example, and then you get to put this to the work. But don't skip this example, because you know how they get harder as they go. Find the least common multiple, the LCM, of these. Holy cow, these are big problems, or big numbers right here, right? We've got 560, 588, and 1,250. Holy cow. Okay, even though they're big numbers, don't be intimidated, because check this out. Once you start dividing, let's divide it by 2, just because it's an even number. So I know that if it's an even number, it can be divided by 2. I get 280 over here. So it starts going down really quickly, right? I can divide that by 2 again, and I get 140. I can divide that by 2, and I get 270. Now 70, I know that 70 is 7 times 10. 7 actually is a prime number, so I can stop there, but 10 is not. I'll do a 2 and a 5. So what are my prime numbers that I got out of this? I got a 5, I got a 2, a 7, a 2, a 2, a 2, because those are all at the end of the branches. Okay, so when I write down my numbers here, it's going to be 2 times 2 times 2. Is there one more 2? 2 times 2 times 2. One more. It's 4 times. And then I've got a 5 and I've got a 7. And then I'm going to erase all of this. Okay. All right, moving on to the next one. 588. I'm going to get a different color so this does not get confusing. 588. So the first thing I'm going to do, that's an even number. So I'm just going to divide it by 2. Now I have 2 and 294. 294 is an even number, so I'm going to divide that by 4, and I get 2 and 147. 147 is a weird number, and I don't know exactly off the top of my head what goes into it, but I don't think it's a prime number. So the things that I commonly check are 2, 5, 10. What about the number 3? So to figure out if it's divisible by 3, I add the digits. So 1 plus 4 is 5. 5 plus 7 is 12, and 12 is divisible by 3. So if I divide this by 3, I get 49. Now 49, since I know my multiplication, is 7 times 7. So, and 7 is a prime number. So now I've got all my primes. I've got 7, 7, 3, 2, and 2. All right, so let's write those down. I'm going to write them in order. 2 times 2 times 3 times 7 times 7. All right, that was fun. That was a fun one. Okay, so I'm going to go ahead and erase. And I bet this one's going to be a fun one too. Let's do the number 1250. Actually, I am going to pick a different color because I don't want these to get confusing and run into each other. 1250. So I know that's divisible by 2, so I've got my handy dandy calculator out. 1250 divided by 2 is 625. Now, 5 is a prime number, so anytime a number ends in 5, I'm just going to go ahead and divide it by 5. Now I've got 5 and I've got 125. Now 125 also ends in 5, so I'm just going to do 5 times 25 to get that. Now 25, I know that is 5 times 5, so that's easy peasy. And now, see, it wasn't that bad. It's a humongous number, 1250, but we got down to the primes pretty quickly. So we've got a 5, a 5, a 5, a 5, and a 2. So let's write that down. We've got 2, 5, 5, 5, 5, 2 more 5s, 5 and a 5. Okay. Erasey. This thing knows what I want now. It's just putting the eraser up there for me. All right, so now we need to find the LCM. So LCM, let's get a beautiful color for the LCM because it's a beautiful idea. Now we're going to go through. Let's start with the number 2. How many times is the greatest number of times it appears? And as I scan through, I see that in 560, in that number 560, it appears 1, 2, 3, 4 times. That's a lot. 2, 2, 2, 2. Okay, 4 times. Now, how about this prime, the number 5? It's 1 time in here in the 560, it's 0 times here, and it's 4 times down here. So I got to write it 4 times. 1, 2, 3, 4. What about the 7? 7 is next. And I see there's 1 time it shows up here, twice it shows up here, and 0 times here. So I need to write it down 2 times. Now, this is my LCM. I can tell this is going to be a humongous number. So if I do 2 times 2 times 2 times 2 times all those, oh, you know what? I forgot one. Let's look back. Oh, I almost made a mistake. What prime number did I leave out? Oh, sad. That 3 is like sitting there going, what about me? I'm here too. So I need the maximum number of times it shows up, which is just 1 time. So I just need 1 3, but what a difference that 3 would have made. And it doesn't matter that I didn't do it in order. I can throw it in at the end because, as you know, associative property of multiplication, it doesn't matter what order you multiply things in, you're going to get the same answer. So I'm going to cheat and look in the book and see what this is because I know it's going to be a humongous answer. And it turns out that the answer is humongous. It is 1,470,000. Bam. There you go. There's the LCM. So that can evenly be divided by 560, by 588, and by 1250. So that's cool. Who knew? Who knew that you could find out these cool things? Alrighty. Now, believe it or not, there's another concept in this lesson. As if you haven't had enough, we're going to be talking about least common multiples of algebraic expressions. So now, not only are there going to be numbers, there's going to be letters in these. This is super fun. So, first of all, let's say you're supposed to add these fractions together. This is an example of when you would use the least common multiple in real life. So you can't just add fractions like this without getting a common denominator. But in order to get a common denominator, you have to figure out the LCM of 4, of 8, and of 12. And then you know how to add these fractions. So the LCM turns out to be 24. And I can kind of just do that in my head just the way I did before, like because these are small numbers. So 12 times 1 is 12. 8 doesn't go into 12. So now let's do 12 times 2. 12 times 2 is 24. These numbers both go into 24. So the LCM is actually 24. So I turn all of these numbers into something over 24 before I add them. So if I turn 1/4 into something over 24, I have to do 4 times 6. That means I have to multiply the numerator by 6, 6 over 24. What about the second one? Now, I have to multiply 8 by 3 to get 24, so I have to multiply the numerator by 3. 5 times 3, 15. Easy peasy so far, right? So, how do I turn 7/12 into something over 24? I have to multiply 12 by 2 to get 24, so I have to multiply the numerator by 2, and that's going to be 14. Now I'm going to add 6 plus 15 plus 14, and I'm going to get for an answer 35 over 24. All right, easy peasy, right? But what is the least common multiple of this? So this, if we were doing a problem like it, it gives this example. What about b over 15a squared b? So this is a fraction just like the one that we just did, plus c over 10ab cubed. Now, just like before, just like this problem, you can't figure it out unless you get a common denominator. So to find the common denominator between this and this, you have to find the LCM between those two. And so that's the next part of this problem. That's the next example. Find the LCM of 15a squared b and 10ab cubed. So what we're going to do is basically the same as before. We write the expressions as a product of factors, okay? But the exponents have to be 1. So the way that I would do that is, let's start with 15 here. I know that 15, they gave us a little bit of an easy one. 15 is going to be 3 times 5, and those are both prime numbers. So I can just write those down. Now what about the a? The exponent has to be 1, so a squared is a times a, and then a b. So I'm just breaking it down into the individual factors with an exponent of 1. The next one, 10, if I break that down, it's going to be 2 times 5. Okay, 2 times 5 times a times b cubed. So it's going to be b times b times b. Now, we're going to find the LCM. And to find the LCM, we want to make sure that we have each factor. We don't want to forget about each thing, just like I forgot about the number 3. We want to use every single one. And you want to use it the greatest number of times that it shows up anywhere. So in this situation, the LCM, I'm going to look back up here, and I'm going to start with the number 3. So I know I'm going to need a number 3 there. And as I scan through, it only shows up 1 time here and 0 times here. So I wrote it just only 1 time. Now, I'm going to go ahead and just check that off because I did that one. What about the number 5? As I scan through, 5 shows up once here and once here. So I only need one number 5 down here for the LCM. And I'm going to go ahead and, whoops, let me just change that. I'm going to go ahead and cross that off because I already used the 5. Okay. Now here's another number down here that I haven't used yet. So I don't want to forget about that little number. So I'm going to write the number 2 down here. Nope, I didn't mean to change colors, but that's all right. And it only shows up once, so I only need to put it once. Now let's do the same thing, but with letters. A shows up once here and twice here, so I need 2 A's. So I'm going to write A times A. And now I've taken care of these A's. What about the B? B shows up once here, and it shows up 3 times here. So I actually need 3 B's. I am going to give myself a little more room. And I'm going to do B times B times B because it shows up 3 times, and now I've taken care of all of these B's. So I used everything, and now I can figure out the LCM. And I just basically multiply it out. So 3 times 5 is going to be 15 times 2, so it's going to be 30. A times A is going to be A squared. And B times B times B is going to be B cubed. So my LCM is equal to 30 A squared B cubed. Okay? Whew, we did it. But it was not so bad, right? Once you know how to do it with numbers, then you know how to do it with variables. Let's do one more example. Find the LCM of 4x squared m and 6x cubed m. So I'm going to write these out. 4x squared m, and break it down into its factors. 4 is just 2 times 2, and I know those are prime numbers, so that's easy. Then I have x times x because it's x squared, and then I have 1m. What about the next one? 6x cubed m. Now 6 is going to be 3 times 2, and I can just write those down because I know that those are prime numbers. I have 3 x's here, and I have 1m. So when I figure out my LCM, I have to use every single factor the maximum number of times. Let's start with the 2's. I have 2 2's here and only 1 2 here, so I need to write it twice. 2 times 2. Now I took care of this and this. Now let's do the x's. I scan through, I have 2 x's here and I have 3 x's here. So I need to write it 3 times. X times x times x. Now I took care of all these x's. Ooh, look, I almost skipped the 3 again. So let's do the 3. And I'm actually going to go back and write the 3 here. Whoops. And I only need one of them because it only shows up one time. So that's the maximum number of times. Now what about this m? It shows up once on the top, once on the bottom. So I only need one m. And now I've taken care of all of them. So my LCM here, if I simplify, or actually do the multiplication, is going to be 2 times 2, which is 4, times 3. 4 times 3 is 12. So 12, and then I've got x cubed here. So I'm going to write x cubed, and then I've got this m. So I'm going to write an m. And that is my LCM for those 2 complicated expressions. Now, is there one more example? Oh my goodness. Oh my gosh. The last example. This is the last melon. Okay, hang in there one more time. Don't skip ahead because you know how they get trickier and trickier each time. Find the LCM of 12x squared am squared and 14x cubed am to the 4th. Oh my goodness. All right, so let's start with 12x squared am squared. Okay, 12, if I break that down, it's going to be 2 and 6. If I break down the 6, it's going to be 2 times 3. So my factors here are 3, 2, and 2. So I'm going to do 2 times 2 times 3. Then I'm going to erase so that doesn't get confusing. And then I'm going to add in my letters. So it's going to be, whoops, I don't like how I wrote that really close. So I'm going to spread it out. And it's a multiplication. So A, there's just one A. And there's, oops, why would I start with the A? Let's start with the X. That's dumb. X times A times M times M. All right. Now let's do the next one. Now we're going to do 14x cubed am to the 4th. So 14x cubed am to the 4th. Please write your workout like this. 14 is what? 7 times 2? And 7 times 2, those are prime numbers, so I can just do that. And then x cubed is x times x times x times another a times 4 m's this time. 1, 2, 3, 4. Okay. Now, what is my least common multiple? I have to grab each factor. Let's grab the 2. How many times is the maximum times it shows up? It's twice there, only once there. I need 2 2's. 2 times 2. Now I've taken care of all my 2's. Now I'm going to grab the 3. There's only one 3 in this whole thing, so I'm going to just add one 3. And I took care of the 3. What about the 7? There's only one 7, so I'm going to write a 7. And I'm done with 7's. Now I'm going to grab an x. So if I grab an x and I scan through, there's 2 x's here and 3 here. So I'm just going to skip a step and write x cubed because I need it 3 times. And then I took care of all my x's. What about the a? There's only one a. So I'm going to write an a. All right. I got rid of those. What about the m? There's 2 m's on top, but there's 4 on the bottom. So I'm going to go ahead and write m to the 4th. And then I took care of all of my m's. I make sure everything is crossed off my list. And now I can multiply this puppy out. Let's multiply it out. LCM equals 2 times 2, which is 4, times 3, which is 12, times 7. What's 12 times 7? Do you know your multiplication of 12? No, I don't. So it's 84. And then I'm going to write x cubed am to the 4th. Bam. I did that. I kind of combined a couple steps there, but I think you're getting the hang of it. So I think we can do that. All right, now's the time to prove yourself with your homework. Take your time, because otherwise you know you're going to have to do those problems again. All right, can't wait to see what you do with it. Love ya. Bye. It's over. Go home. It's over. Go do your homework. You can go do your homework now. The lesson's over. Why are you still here? Okay, bye.